If you don't remember how to write a straight line equation, you should watch this video before continuing. Now let's see how a thermometer works and what is the relationship between the temperature and the height of the liquid. The calibration of any measuring tool involves the placement of divisions or marks upon the tool to measure a quantity accurately in comparison to known standards. The tool needs divisions or markings. The typical process to calibrate a thermometer involves using the freezing point and the boiling point of pure water. By placing a thermometer in mixture of ice water and allowing the thermometer liquid to reach a stable height, the 0-degree mark can be placed upon the thermometer. Similarly, by placing the thermometer in boiling water and allowing the liquid level to reach a stable height, the 100-degree mark can be placed upon the thermometer. With these two markings placed upon the thermometer, 100 equally spaced divisions can be placed between them to represent the 1-degree marks. With a calibrated thermometer, accurate measurements can be made of the temperature of any object with the temperature range for which it has been calibrated. One of the chief reasons why mercury is used for filling thermometers is that it expands regularly. The height of the liquid column is proportional to the increase in temperature. I mean that for the same temperature change, we will have the same change in the column length of the liquid. Suppose that a 10-degree increase in temperature causes a 1 centimeter increase in the column's height. Then, a 20-degree increase in temperature will cause a 2 centimeter increase in the column's height. And a 30-degree increase in temperature will cause a 3 centimeter increase in the column's height. The relationship between the temperature and the column's height is linear over the small temperature range for which the thermometer is used. Suppose I take a ruler and measure the distance between 0 and 100 degrees Celsius at 10 centimeters. Since there is a linear relationship between the temperature and the height of the liquid, we can draw a graph to show us how the height changes with the temperature. Pay attention. 1 centimeter corresponds 0 degrees Celsius. 11 centimeter corresponds 100 degrees Celsius. Draw the line. Take the equation of the straight line. B is y-intercept. And now let's calculate the gradient. The gradient is y change over x change. In this case, y change is 10, x change is 100. Substitute into the formula. Let's see how it works. Example, the distance on thermometer between the 10 degrees Celsius mark and the 50 degrees Celsius mark is 20 centimeter. Calculate the length of the liquid thread above the 0 degrees Celsius mark when the temperature recorded is 40 degrees Celsius. To determine the relationship between Celsius and height, we draw a graph. Height versus Celsius. "20 centimeter corresponds 50 Celsius. Take the equation of the straight line. Y-intercept is 0 in this case. Calculate the gradient. This formula allows us to find out the temperature in degrees Celsius as a function of the height in centimeter. Substitute the value given in the question. It's done. A thermometer can be calibrated using the Fahrenheit scale in a similar manner as was described above. The difference is that the normal freezing point of water is designed as 32 degrees and the normal boiling point of water is 212 degrees in the Fahrenheit scale. As such, there are 180 divisions or intervals between these two temperatures. When using the Fahrenheit scale, we can draw a graph to show us how the height changes with the temperature. We will make the same. As we did before. Take the equation of the straight line, calculate the gradient. You should note that in this case, we don't have the y-intercept. When the height is 0, the temperature is 32 Fahrenheit. We find out the B. This is the formula. Let's see how it works. The distance on thermometer between the minus 50 degrees Fahrenheit mark and the 250 degrees Fahrenheit mark is 15 centimeter. Calculating the length of the liquid thread above the minus 50 Fahrenheit when the temperature recorded is 160 Fahrenheit. Pay attention. Let's draw the graph. The temperature in Fahrenheit versus height. Draw the line. Using the general equation for a straight line, calculate the gradient of the straight line. Substitute into the formula. When the height is 0, the temperature is minus 50 degrees Fahrenheit. Substitute the value given in the question. It's done.